Hello, this is Justin Beall. I'm a staff engineer at Artium, and I want to take you through using AI assistance for helping with software development. We're going to be working on a problem called the Gilded Rose Kata, which is a traditional Agile problem centering around refactoring code base and implementing a new feature. The tool we're going to be using is called Cursor.sh. Instead of being a plugin to Visual Studio Code, they call it an AI IDE, so an artificial intelligence integration development environment. We have a repo set up for the Gilded Rose Kata. It's in Python. You want to go through the README real quick just so we can all understand the problem. So here's the overview. The Gilded Rose Kata is a classic code kata for practicing refactoring skills. It involves a small inn with a prime location in a predominant city run by a friendly innkeeper named Allison. The inn sells only the finest goods, but unfortunately, the goods degrade in quality as they approach their sell-by date. Your task is to add a new feature to this existing system. Gilded Rose Requirement Specification. Hi, and welcome to Team Gilded Rose. As we are a small inn with a prime location in a prominent city run by a friendly innkeeper named Allison. We also buy and sell only the finest goods. Unfortunately, our goods are constantly degrading in quality as they approach their sell-by date. We have a system in place that updates our inventory for us. It was developed by a guy named Leroy, who has moved on to new adventures. Your task is to add the new features to our system so that we can begin selling a new category of items. First, an introduction to the system. All items have a sell-in value, which denotes the number of days we have to sell the item. All items have a quality value, which denotes how valuable the item is. At the end of each day, our system lowers both values for every item. Pretty simple, right? Once the sell-by date has passed, quality degrades twice as fast. The quality of an item is never negative. Aged brie increases in quality the older it gets. The quality of an item is never more than 50, but sulfurous, a legendary item, and as such, its quality is always 80 and it never alters. Backstage passes, like aged brie, increase by 1 in quality as its sell-in date approaches. Quality increases by 2 when there are 10 days or less. Quality increases by 3 when there are 5 days or less. Quality drops to 0 after the concert. Conjured items degrade in quality twice as fast as normal items. Feel free to make any changes to the update quality method and add any new code as long as everything still works correctly. However, do not alter the item class or item property as those belong to the goblin in the corner who will insta-rage and one-shot you as he doesn't believe in shared code ownership. You can make the update quality method and items property static if you like. Just for clarification, an item can never have its quality increase above 50. The Gilded Rose Kata is a pretty standard kata. It's done in many languages. If you go to the original source, we can see that it ranges from A to C, Java, MATLAB, R, all these languages you can find examples of this to do in. So although we're going to do ours in Python, if there was a specific language you want, you can do the same things and work through the tool and try the same experiments as I do. The first step is following the README and cloning down the kata locally and making sure we can run our main function and our tests. We'll follow the setup instructions here. It says clone this. We're going to go into our terminal and perform the git clone. That has pulled down our repository, and now we're going to actually change directories to that specific kata that we have. At this point, the README says to brew install Hatch. Hatch is a environment management system for Python. This project requires Hatch in order to run our tests in our main program. So what we're going to do is we're going to follow the README and we're going to brew install Hatch. We have Hatch installed and we have our repository pulled down. What we're going to do is we're going to open it up. And Cursor.sh is one of my favorite AI assistant tools right now for helping with software development. You can reach it at cursor.com, and as they say, it is the AI code editor, built to make you extraordinarily productive. Cursor is the best way to code with AI. And what I have found is that it takes all the features that GitHub Copilot has and adds on top of them. And instead of being a plugin to an IDE, the IDE itself is the AI assistant. So there's some stuff here. If you wanted to learn about it, you could go ahead. It's got auto-completes and a lot of other things that you'd expect out of a AI assistant. You can ask questions and it has a chat window and some other stuff. So I've already downloaded it and let's open it up. the project we just cloned down. With Cursor.sh open, we're going to try to fill in some gaps in knowledge and go deeper on our subject. Let's say as we're reading the README, we looked around and we noticed that it said to use Hatch. Hatch is a environment and deployment management tool for Python. So what we're going to do is we're going to open our chat window in Cursor, and then from here we could select a model. We have GPT-4o, some built-in Cursor ones, other things, and then even the new GPT-4o Mini that just released a few days ago, and then Cloud if you're interested in that. What is Hatch for Python? Hatch is a modern project management tool for Python that helps manage dependencies, virtual environments, and packaging. It aims to simplify the development workflow by providing a unified interface for various tasks such as creating virtual environments, running tests, and building packages. Why would you use Hatch? Unified tooling. Hatch combines multiple tools in one, reducing the need to switch between different tools for environment management, dependency management, and packaging. Easily create and manage isolated virtual environments for your project. Simplifies the process of specifying and installing dependency configuration in a single PyProject TOML file. Streamlines the process of building and publishing packages to PyPI or other repositories. Integrates with testing frameworks and runs easily. So that's awesome. Now it's telling us how Hatch works. They say pip install Hatch. We use Brew. Project initialization. Here's how we can do a new Hatch project. Hatch m create, which we're doing in our actual README, and then activate the shell, and you can see it's here too. Dependency management. Add dependencies to your PyProject TOML file and install them. So we can say hatch and install, and then we can run a script. This is similar to do a package JSON in the JavaScript world where you can have specific scripts set up to run. And that's what are set up over here, such as we have hatch run Gilded Rose, hatch run text. Building and publishing. So if we wanted to actually publish, we could do that too. And then it actually even gives us an example of a PyProject TOML. If we look in our project, we have a PyProject TOML. Can you explain the parts of this PyProject.toml to me, please? I am new to that. Certainly, let's break it down. So it's talking about the build system. This section specifies the build system requirements. Required list packages needed to build the project. Here it specifies Hatchling, which is a lightweight build backend for Hatch. It explains our project. So you can see it tells us what the name, dynamic versioning, descriptions, license, README, authors, all those things. And it breaks down basically our PyProject TOML one by one. So using our AI tools, we can fill gaps in knowledge and go deeper in on subjects. This includes our tools and utilities within our projects, but also could be applied to the domain and other things that we are interested in. We're now on our ways to becoming experts in anything we want. Now, we're going to use our assistant to help us quickly understand a new code base. Oftentimes, we're thrown into new projects or existing projects with a lot of legacy code, and where to begin can be daunting. So we're going to try asking our Cursor.sh chat window about the project and see what it comes back with. Let's say, could you explain this project to me? What are the main functions? What are any particular highlights? Can you describe any of the important code files? And then here, I'm going to hit Command Enter, so it's going to scan the entire code base. As we can see, it's looking through the entire code base. And what we've done without even looking at a single line of code gives us a good overview. Project overview. The Gilded Rose Kata is a classic kata designed to practice refactoring skills. The project simulates an inventory system for a small inn that sells various items, each with specific rules for how their quality degrades or improves over time. Main functions. So it has an item class, represents an item in the inventory, attributes, name, sell, and quality. The Gilded Rose class manages a list of objects. It has a main method, which is update quality, which updates the sell and quality attributes for each item based upon the specific rules. Key highlight. Quality rules. All the items have a sell-in value, days to sell, and quality, value of the item. Quality degrades over time, but some items have specialized rules. Age increases quality as it ages. Sulfurous is a legendary item with a constant quality of 80. Backstage passes increase in quality as the event date approaches, but drops to 0 after the event. Conjured items degrade in quality twice as fast as normal. And this conjured item is what we're going to be implementing in our kata. Constraints. Quality is never negative. Quality never exceeds 50 except for sulfurous. Important code files. So then it's just giving us an overview of what is actually in the system. Using our chat assistant, without even opening a single code file, we can get a general idea of what the code base is about. Now I'm going to say @shell, so that way we're set up like this. And then I can run a script called #run Gilded Rose. Let's see what that does. We're going to ask our assistant what this output means. Can you explain the output for me? Just paste it there. Certainly, the output shows the state of the inventory of the Gilded Rose in over 2 days. Each item has a name, sell-in value, which is the days left to sell the item, and a quality value. Here's a breakdown of the output. Day 0, the initial state. So it looks like it has 10 days to sell, quality of 0, and describes all of our items for us, right? But then what we see our assistant has helped us out with explain the difference between the first and the second. So Dexterity Vest has 9 days to sell, 19 quality, its quality decreased by 1. Age Free, which was one of our special items, had its quality increased by 1. Elixir of Mongoose, quality decreased by 1. That's a normal item. No matter how many days are left, its quality always stays at 80. Then we have some information about backstage passes, and then our Conjured mana key. We don't have this actually work in the output correctly, as the quality decreased by 1, but it's supposed to degrade twice as fast. And here's some key points. Normal items, as the ones listed, decrease in quality by 1 each day. Age Brie increases quality as it ages. Sulfurous is a legendary item. Quality does not change. Backstage passes increase in quality as the concert date approaches, with specific rules for different time frames. Conjured items degrade twice as fast. And it says this output helps verify the system correctly updates the inventory according to the specified rule. Assistance. Let's move on to pinning down legacy code with tests. Now that we have our work environment set up, our dependencies installed, and we understand what the main program does, let's see what kind of testing exists in the system. So we're going to scroll down to the README, and there is a test. This #run test. Let's run that on the terminal. And what we see, unfortunately, this test fails. It's left as a breadcrumb to help our Kata participant know where to start. So if we look at this, we can actually take this right here, and we'll say, inside of our chat, we'll say, this test failed. And you help. This is the test failed because the assertion is checking the name of the item as fix me, but the name of the item is poo. The method does not change the name of the item, so the assertion will always fail. To fix this, you should assert the expected behavior of the update quality method. For example, you might want to check the sell-in and the quality were updated correctly. Let's move over to our test file, and with Cursor.sh, we can click on this, and it brings us directly to the file. We're going to put those asserts in there, and what we can see is that it's pretty simple. The item is foo, and it says fix me. So we're going to switch this to foo, because in a legacy system, we're going to assume the existing behaviors are what users are used to, and the code works as well as it should, even though there is no testing. Let's try running our test again and see what happens. And with that, we can see that we got a passing test. And the README also gave us another cool hint. Using something called coverage gutters, we can actually watch the test coverage, and we want to make sure that we have 100% code coverage or whatever number you feel is adequate before moving forward with refactoring or updating our existing code base. I'm going to do a Command-Shift-P, and then I have coverage gutters watch. I'm going to select that. And then if I go over to the Gilded Rose, I can see just by fixing that one test, I had some things actually covered, which is my green. Things that are not covered is my red. We got a decent amount of coverage from just fixing that one test, but we are far away from being confident that our test pinned down and cover the existing. Okay, let's say, can you write unit tests for the update quality function to cover most of its functionality? And then I'm going to hit Command Enter so it knows about the entire code base, so it can look at the existing tests and its current context. Then it went through and it produced us this test file. Seems like it has normal items after sell-in with 0 quality, aged brie, sulfurous, backstage passes, and conjured items. Although our conjured items are coming up. Now, let's run our test. We have 2 failures now. We can see that we have the conjured items. Those haven't been implemented yet. So we're going to remove those and try running our test again. And just by doing that, we've increased our coverage to 90%. Let's take a peek over at the Gilded Rose and see what is not covered. Use our coverage gutters. And we can see that we're missing this down here. I'm going to ask our assistant to help us out with this. Can you please write a unit test that will cover these lines of code? Okay, so certainly I write unit tests to cover the specified lines of code in the update quality map. The goal is to ensure that each conditional branch is tested. Absolutely. So we have right here in our output, it actually tells us additional tests to cover specified lines of code. We're going to take those and we're going to put them right into our test. And then we're going to run our test again. And beautiful, we can see that our Gilded Rose file is up to 100% test coverage. But now the last thing is the item.py file is not covered. Although we're not supposed to write code for the item.py, there's no reason we could not write a test for it. So I'm going to do the same thing here and ask our assistant, can you write a unit for this file that tests the underscore reffer function? Certainly, here's the test. Great, it looks pretty simple. We're going to come over here and we're going to create a new file and we're going to call it item SI. And then we're going to just click the button. Beautiful. And now if we run our test, we have 100% code coverage. And here in a couple minutes, what we've seen is that we can take a code base that we're not very familiar with and use our AI system to pin down all the legacy functionality with our test. We pin down our code base and test, and we have 100% coverage. We're in a good place to start refactoring. And we're going to use our AI assistant to help with that. What's great is AI can easily identify and recommend code improvement and suggestions that enhance readability, performance, and make. We're going to leverage our AI to do this. So first, let's start off with our test we're most familiar with. So we're going to go into our test, and you can see we have a lot of tests here. And we're going to ask our AI, can you refactor the tests? Like there is a lot of refactoring. Can you put them into some hard code? Let's send that and see what it comes back with. And if it's certain, we can use PyTest and parameterized tests to reduce the duplication. Here's how you can refactor those tests. So we're going to copy everything we had here. We're going to paste it over. And we see that instead of having individual test cases that check out our various things, we now have everything in a nice parameterized test where we can see what is going on. We have our normal item, we have our sulfurous, we have our backstage passive, and a lot of things that go around there. Let's run our test again. And we still have 100% code coverage. And we have a nice, more condensed way of viewing all of our tests. Next, let's go on to the actual code itself. So if we look, we have a lot of nesting. There are a lot of magic numbers, a lot of hard-coded values, and the overall complexity is just hard to follow. So let's try this with our AI system real quick. Let's say, can you help me refactor this code to be more maintainable and understandable? Question mark. It should duplication. See what it turns out. Certainly, we can refactor the update quality method to be more maintainable and reduce duplication by breaking it down into smaller, more focused functions. Here's a refactored version. So if we look at it, it has taken the update quality, it's looping through each one, updating the sell-in and updating the quality. It's skipping over our sulfurous, the sell-in, the quality. Great. So we're going to take this, and it's very important when asking AI to update your code that we run tests after every update so we know whether or not we have introduced any regression. We're going to run our test again. And look, we're still at 100% coverage. All right, let's look at what it did. It created an update sell-in function, an update quality function. It still has a lot of hard-coded strings. It has a lot of magic numbers. So what I'm going to do is I want to ask it to remove the hard-coded string and magic number. It says, certainly, we can refactor the code to use constants for the hard-coded strings and magic numbers. This will make the code more maintainable and easy to update in the future. So with just that one change, we're going to copy what it did and we're going to paste it. We're going to run our test again. And we're still at a good coverage amount. Now that we've removed the magic numbers and hard-coded strings, and we have our test passing, it looks like a lot of the logic is baked into each of the functions. So when I had to add a new item, I'd have to type it many different places. What I want to do is try to ask our assistant to help us out here. It looks like the logic for updating the various parts of an item is contained within each function. As the Conjured mana item, I am going to have a lot of pieces of code. Instead I would like to just update or add a function handle the conjured and items. See what it comes back with. Here, let's refactor the code to be more functional. We create separate functions for each type of item, use a dictionary to map the names to the respective update function. This way, adding a new item type will be as simple as adding a new function and updating the dictionary. That sounds great. Let's copy this and let's see what we get. We don't need the actual item class here. This should come from our item that our goblin made. So I'm going to import that and we're going to run our test again. When we've introduced something such that we're still not have something covered. Oh, our conjured matter items. So with that a little bit ahead of time for us, I'm going to remove that. It's just not part of our currents. We're just refactoring. We're not trying to add new functionality. And what we can see is we have this list of update functions where if it's a degree or backstage pass, it's going to grab the function, update the item, and then handle the expired items if it's there. Expired item still has a bit more complexity than I want inside of it. Let's see if we can take it a step further. The expired items function still has a lot of complexity based on the item type. Is there a way we push this into the updates for each item type? And so certainly we can refactor that. Well, let's see what it did. All right, so now it took out that handled expired item and everything is just focused on the item type. So we're going to take this and we're going to replace our code. Going to paste. So what I see right here is we have an if check that we could probably get rid of. I'm going to ask the AI assistant to filter those out instead of having our if statement nested within for loop. And we filter out the purest items instead of for loop. Certainly, we can filter out the suffers and for entering the loop. This will make the loop clear and avoid unnecessary checks. So if you look again, we're just going to update our function here. That way we don't have our if check in here and it used a list comprehension and filtered everything else. I'm going to test one more time. And there we go. We've effectively refactored the Gilded Rose file to be a lot more readable and maintainable. More things we could do, but we're at a good place such that we've made the change easy and make the easy change. With our code refactored and in a good state, we're going to use our AI assistant to help us with test-driven development. Test-driven development with an AI assistant is similar to traditional test-driven development, except we need to prompt our assistant to let it know that we only want to work iteratively, one test at a time in our red-green refactor loop. Using our test-driven development approach, we're going to ask it to help us out. We will make sure that we let it know that we want to follow PTP. I need to help me out. I want to take a test-driven development approach following the red, green factor. Could you please provide me with a test and only continue when I have indicated that I have a failing test in my case. And when I am ready, we can go to the implementation. Please only provide one step at a time so I can work through your loop. Sure, let's get started by writing a test for conjured items. We'll create a new test file called the Gilded Rose test and add a test case for conjured mana cake. Well, let's take this test and we're going to go over to our Gilded Rose test. And what we're going to see is when we run our test, we're going to have a failure. Great. We have a failing test. Now let's implement the logic for conjured items in the Gilded Rose class. We'll update the update quality method to handle conjured items. All right, we have a failing test. Now let's implement the logic for the conjured items in the Gilded Rose class. We'll update the update item quality method to handle conjured items. Here's the updated code. Now what I'm going to do here is I'm just going to hit the button. Just go through and I'm going to accept that one. And what else did it do? It looks like it added our conjure item. That successfully added our new code in line. We're going to run our tests. Our test still passed, but what we can see is that we haven't hit this line right here. This is great. And we move on to the next test that verifies that the quality is degraded twice as fast when it is passed. Let's add a new test case for that. Beautiful. So we're going to grab this test case and we're going to paste it over here. Okay. And then let's run our test again. And with that, we've implemented our feature. But now we're at the refactor loop. So what can we do? I noticed that we've added a couple new test cases. These could probably be folded into our existing parameterized test. Let's say, can we refactor this test to include our new test cases in our parameterized test? And it's like, sure, here we go. It's gone through and edited our new test cases. So we can just hit the apply again and hit accept, and it moves things to where we need to go. Run our test one more time. Great. Let's do our final step of adding documentation to the code base. Our AI assistant is great for that. It can automate the creation of comprehensive documentation based on existing code, whatever user stories. It can generate Swagger documentation from our APIs. It could help us update our READMEs. So what we're going to do now is we're going to go to our chat window and say, could we add documentation to this text file? But I would like to focus more on UI comments and make sure future maintainers can easily add adjustments if necessary. I'm going to let that fire. Sure, I'll add some concise documentation to the test to help future maintainers understand the logic and the purpose of the tests. Beautiful. Let's take this. We're going to copy and paste it. And then we're going to run our test just to make sure everything passed still. And we're going to review the comments. Okay. Parameterized tests for different item types and their expected behavior. Love it. Normal items degrade in quality by 1. So it's letting our future maintainers know what they are going on. A special test case here for the quality is never negative. Information about age debris, our sulfurous, special cases around our backstage passes, some additional age debris test cases, which I'm going to move those up to all by each other. Normal items degrade in quality 2. I'm going to move this up too, because I feel like that is important. We'll just keep everything co-located together. And then our conjured items degrade quality twice as fast as normal items. And then we got some kind of PyDoc style documentation about the individual attributes, the individual inputs of the function, and what they are expected to do. Now let's move on to the Gilded Rose file. Can you create similar documentation for the Gilded Rose file? So certainly add concise documentation in Gilded Rose class, its methods to help future maintainers understand the logic and purpose of the code. All right, let's copy all that, paste it on over. As always, we're going to run our test first, and we're still passing. And let's look at what it added. The Gilded Rose class is responsible for updating the quality and selling values. That's beautiful. It gives us what the init does, initialize the Gilded Rose Kata with a list of items. It tells us the update quality. Update the quality and selling values of items in the inventory. That makes sense. Update sell-in. And we get similar PyDoc style documentation for all of our functions. And with that, we've properly documented our code, helping assist future maintainers be more productive in our code base. And that's it. To recap, we focused on how AI can help us fill in gaps of knowledge and go deeper on subjects through our Hatch example. We used AI assistants to quickly understand a new code base before even looking at the code. We wrote pin-down tests for our legacy code and achieved 100% code coverage before doing any refactoring. We used our AI assistant to help us refactor both our test and our code base. We adjusted our prompt as we were coding to focus on a test-driven development fashion and used our AI assistant to help us with that. And finally, we used our AI assistant to help write documentation. Thank you for joining me on this adventure through the Gilded Rose Kata using AI assistants. I hope you enjoyed this video. Leave your thoughts and comments below. Have a good one.